key idea in section 8.1 is when you have a right triangle and you drop down in altitude from the right angle, there will be three geometric means. The original biggest right triangle's small leg, the altitude, and the long leg. Again, that's the small leg, the altitude, and the long leg. For each geometric mean, they get their own proportion. For each geometric mean, they get the leading role in a proportion, showing up twice in a diagonal. What is why the geometric mean of all of these geometric means will be the middle of stuff happening down here that's not highlighted. Things on the original triangle's hypotenuse, either this part, that part, or the whole thing. So let's begin with y. Y is a geometric mean of z and the whole hypotenuse. Y is the geometric mean of z and the whole hypotenuse. X is the geometric mean of z and 18. And 6 root 13 is the geometric mean, the perfect multiplicative middle of these two things, which are 18 and the whole hypotenuse. So remember, this leg is a geometric mean of the part of the hypotenuse that it's touching and the whole hypotenuse that it's touching. The blue one is a geometric mean of the part of the hypotenuse that it's touching and the whole hypotenuse that it's touching. And the middle geometric mean, the altitude, is the geometric mean of each of the parts that it's touching. All right, when you solve problems like this, identify the three geometric means and set up all three of their proportions before you solve any of them. Because if you set this green one up and you try to solve it, you'll get frustrated because there's two different letters, z's and y's. Same thing if you set up the red one first and try to solve it. There's x's and z's. This one has only the letter z. So we know this is the one we want to solve first. And then once we know z, we can substitute it into the other ones and find the other letters. All right, when you solve this proportion or any other one, always start by writing your equal sign. And now we're going to establish what's on the left and what's on the right by cross multiplying. So 6 root 13 times 6 root 13 will be on the left, and z plus 18 times 18 will be on the right. And be sure to put that z plus 18 in parentheses because it's the entire numerator that's cross multiplying with 18. So we have to use parentheses and the distributive property. 18 times z and 18 times 18. Now on the left side, when you multiply these expressions, 6 is on the outside and 6 is on the outside. So 6 times 6 is 36 on the outside. And then we've got the square root of 13. 13's under the square root, 13's under the square root. So we can multiply them under the square root. That's 13 squared. And 13 squared is a perfect square. The squared cancels out with the square root. The square root of 13 squared is 13. So we have 36 times 13 is equal to 18z plus 324. All right, subtracting 324 from both sides, we get that. And dividing both sides by 18, we have z is equal to 8. Now that we have that, we can find x and y. So if z is 8, then we have y over 8 equals 8 plus 8 over y, and x over 8 equals 18 over x. And cross multiplying, we quickly find x and y. Y times y is y squared. 16 times 8 is 128. And taking the square root of both sides, y is equal to the square root of 128. Or that simplifies to 8 root 2. X squared equals 18 times 8. When you take the square root of both sides of those, x is equal to 12. So x is 12, y is 8 root 2, and z is 8.